Swayam Prabha. Digital India. Educated India.
Hello learners, the video is for the subject of Geography for the course of Bachelor's in Arts with Geography or Bachelor's in Arts with Honours in Geography. The video is for the paper of Climatology. Today we will be studying Lecture 3 of Module 6. The topic of the lecture is Tropical Cyclones, their origin, characteristics and associated weather conditions. The video is being recorded by Dr. Pallavi Upreti. This particular video on tropical cyclones is quite big. Therefore, it has been deliberately divided into two parts. The course coordinator and presenter for the video is Dr. Pallavi Upreti, affiliated to Department of Geography, Doon University. The academic expert and reviewer for the video is Professor Santosh Verma, Head of the Department, Department of Geography, SDM PG Government Degree College, Doiwala, Dehradun, affiliated to Shri Dev Suman, Uttarakhand University. The video is produced and presented under the project name DTH Swayam Prabha Channels of MHRD, New Delhi, India. Hello dear learners, I am Dr. Pallavi Upreti, Assistant Professor in the Department of Geography in Dr. Nityanand Himalayan Research and Studies Center, Doon University, Dehradun, Uttarakhand. We are studying Module 6 of Climatology, which is associated with the formation of fronts, frontogenesis, formation of cyclones, and anticyclonic conditions in our atmosphere. In the process, today in this particular module, we will be studying about tropical cyclones, their important characteristics, their origin, their path, their movement, and various weather conditions and patterns which are associated with tropical cyclones. So let's begin. Before starting this video on tropical cyclones, I would like the learners to please note down that this particular video lecture on tropical cyclones is being bifurcated into two parts for the ease of learners to understand the topic, since the particular video is quite extensive. So the first part of the video will cover from topic 1 to 5, while the second part of the video lecture will cover from topic 6 to 10. Now, starting with the objectives of part 1 of this particular video. In the due course of this particular video, the learners will be able to understand in general what are tropical cyclones, what are the regions where these tropical cyclonic activity is very prominent, and then what are the conditions for the development of tropical cyclones. And finally, we'll be understanding what is the mechanism for the formation of tropical cyclones, how they origin, and what is their global distribution, and how once they form, they move in different regions of the world. So these 5 topics will be extensively covered in this particular part 1 of the video. Starting with the basic understanding and definition of tropical cyclones. A tropical cyclone is a rapidly rotating storm system characterized by a low pressure center, a closed low-level atmospheric circulation with strong wind flow, and spiral arrangement of clouds that produces heavy rain and squalls. So just like temperate cyclones, the tropical cyclones also have low pressure central core region, because of which the winds gushes from the outer peripheral regions towards the center of low pressure. And as the name suggests, tropical. So unlike the temperate cyclones which are found in the temperate regions of the world, the tropical cyclones, as the name suggests, are located between the Tropic of Cancer and Tropic of Capricorn. So the geographical extent of their origin is mainly concentrated between the Tropic of Cancer, that is 30 degrees north, to Tropic of Capricorn, that is 30 degrees south in both the hemispheres. And within these tropical regions also, they primarily develop over the tropical warm oceans of the world. So, a tropical cyclone is a rapidly rotating storm originating over warm tropical oceans from where they draw their energy to develop and become extensive over the course of time. Tropical cyclones are extreme weather disturbances which are associated with the low pressure central core region, which is called its eye also. And generally it has spiraling arrangement of clouds which accumulate towards the eye wall, which is the region which surrounds this low pressure central eye region. Hence it is called as eye wall. And in this eye wall you have spiraling arrangement of clouds. But the central eye region, which is the lowest pressure region of the cyclone, is mostly associated with calm, clear and free from clouds conditions which exist in the cyclone. So as you can see in the diagram also, that you have the central region which is called as the eye of the cyclone. And around the eye you have the eye wall, and from the eye wall towards the peripheral regions you have this spiraling arrangement of clouds also. And as the wind gushes towards this low pressure center, the air condenses and it leads to the formation of clouds around this eye wall. And generally the central region is mostly free from any type of turbulence. It is calm, it is clear and it is free from any cloud formation activities. And along the outer margins you can also see the spiraling rain bands, which leads to heavy precipitation when this tropical cyclone hits any region. So basically, tropical cyclone is a weather system which is associated with turbulent weather conditions. They are extreme weather disturbances with violent wind and weather conditions. The wind movement in the tropical cyclone is mostly from the high pressure outer regions towards the low pressure central core region, and the winds whirl around the central low pressure region, which is also called as the eye of the tropical cyclone, and they blow anti-clockwise in the northern hemisphere and clockwise in the southern hemisphere. So the wind movement in tropical cyclone is anti-clockwise in northern hemisphere and it is clockwise in southern hemisphere. So these systems, these tropical cyclones have diameter typically around 200 to 500 kilometer, but it can also reach to 1000 kilometers on occasions of extensive tropical cyclone development activity. And these tropical cyclones bring very violent winds, torrential rain, high waves, and in some cases very destructive storm surge and coastal flooding is also associated with the tropical cyclone development in any region, because of which these tropical cyclones are also considered as the notorious violent weather systems which exist on our planet, because they cause mass destruction in regions where they develop. So, why do tropical cyclones originate in the tropical regions of the world only, which extend between 30° north to 30° south in both the hemispheres? That is, between the Tropic of Cancer in the northern hemisphere to Tropic of Capricorn in the southern hemisphere. So what is the reason that tropical cyclones develop in these specific latitudinal belts of the world only? It is important to note here that since the tropical regions of the world receive direct insolation from sun throughout the year, even with the apparent movement of the sun to the northern hemisphere in the June-July time period and to the southern hemisphere in the December-February time period, even with this apparent movement, the tropical latitudes received direct insolation throughout the year, because of which the average temperature of these areas within these latitudinal belts remain high throughout the year. And as we have studied in the first slide, that the tropical cyclones primarily originate over the tropical oceanic waters of the world only. And we also know that water requires more time to get heated and requires constant heating as compared to land. Because of this specific property of water to take more time to get heated, these tropical regions of the world provide the most conducive conditions for the formation of tropical cyclones, since these regions of the world receive fairly high insolation throughout the year. So tropical cyclones primarily originate within this belt. And it is also important to note that this belt migrates northward with the apparent northward movement of the sun, and it also tends to migrate southward with the southward apparent movement of the sun as the earth revolves around the sun in a particular year time period. So these cyclonic belts also tend to shift a bit northward during the cyclonic activity and may sometimes impact the areas which lie beyond the tropical regions of the world also. But primarily, these tropical cyclones are concentrated within the intertropical convergence zone. As you have studied in module 3, that somewhere around 23.5 degree north, that is Tropic of Cancer, and 23.5 degrees south, that is Tropic of Capricorn, you have subtropical high pressure belt which is running in both the hemispheres, and this is a high pressure belt. So this subtropical high pressure belt exists in both the hemispheres, and these tropical cyclones primarily develop in the intertropical convergence zone, because we have studied that these regions of the world are dominated by the movement of trade winds which blow from subtropical high pressure belt towards the equatorial low pressure belt which is found near the equator. Since trade winds are very dominant in these regions and they blow from subtropical high pressure belts towards the equatorial low pressure belt, within these regions, the tropical cyclonic activity is very prominent in this intertropical convergence zone region. So to summarize, the tropical regions of the world receive direct high insolation throughout the year, because of which they create conducive conditions where the sea water gets warmed up and create conditions for the formation of tropical cyclones, because of which these tropical cyclones develop over the tropical warm oceanic waters. And once they develop, since they are located within the trade wind belt zone, they mostly move westward under the influence of trade wind. As you can see in the diagram, that as they are formed in the intertropical convergence zone region of the trade winds, and as the movement of the trade winds is primarily westwards, you can see here in the diagram, these tropical cyclones once formed also move westward. Because of all these conditions, the tropical regions experience most intense cyclonic activity, specifically in the summer season and late summer season in both the hemispheres. Besides latitudinal location, several other conditions are necessary for the development of tropical cyclones. First and foremost condition in this series is the existence of high sea surface temperature and abundant supply of warm and moist air. The high sea surface temperature is ensured by their latitudinal location, which is primarily located within the tropics. And since the tropical regions of the world receive fairly high insolation throughout the year and have average high temperature also, the oceanic surfaces in these tropical regions of the world is able to maintain the high sea surface temperature, which is one of the primary requirement for the formation of tropical cyclone. And the existence of this high sea surface temperature ensures the abundant supply of warm and moist air. So tropical cyclones only form over the warm tropical oceans, and as they need source of both heat and moisture, These cyclones originate over the warm ocean surfaces having sea surface temperature greater than 26 degrees Celsius. So the requirement of 26 degrees Celsius and more temperature is very important for the tropical cyclone formation, and if the sea surface temperature is not able to reach this required temperature, the tropical cyclones do not develop in these regions, and this 26 degree Celsius temperature is required to a depth of at least 60 meters during the summer season. And as we have studied in the earlier slide, that these cyclones primarily developed within the tropical regions of the world, which extend between 30 degree north and 30 degrees south in both the hemispheres. But it is also important to note that they are not found within the 5 degree north and 5 degrees south of the equator, because cyclones are rotating system, and strong rotation of winds of tropical cyclones are the result of conservation of angular momentum imparted by the Earth's rotation and existing Coriolis force. And as the air flow inwards towards the axis of rotation, but this Coriolis force is minimum at equator, that is 0 degree, because of which the formation of tropical cyclones is very rare between 5 degree north and 5 degrees south of equator in both the hemispheres. But from 5 degree to 30 degree in both the hemispheres, these cyclones are very active. And these tropical regions of the world are also the regions where the trade winds converge, since we know that trade winds move from the subtropical high pressure belts towards the equatorial low pressure belt. So these regions of the world are also marked by the convergence zone of the trade winds. So one of the condition is that they are associated with the intertropical convergence zone, which extend between the 5 degree north to 30 degree north in the northern hemisphere, and from 5 degrees south to 30 degrees south in both the hemispheres during the respective summer season. And majority of the cyclones also originate within this particular belt, which extends from 5 to 30 degree north and south in both the hemisphere, and they are primarily concentrated in the western parts of the oceans. Why? Because once these cyclones are formed in the trade wind belt, they are dragged by the trade winds towards the western parts of the oceans, which are found in these tropical belts. Now, besides the conditions which we have discussed, we have few additional conditions also, which not only helps in the formation of tropical cyclones, but also helps in the intensification and creation of very extensive tropical cyclones. So the existence of anticyclonic conditions at the height of 9 to 13 kilometers above the surface of disturbance at the ground, it leads to the maintenance and suction of the warm air which rises from the tropical warm oceans, and it helps in maintaining and intensifying the low pressure center at the surface. So this we have discussed in various videos, that if you have a low pressure center at the ground surface, and if you have well developed anticyclonic conditions or high pressure in the upper atmosphere, it continuously channelizes the warm air which is ascending from the low pressure regions, and the existence of these anticyclonic conditions or high pressure in the upper atmosphere maintains this suction of air which is coming from the ground surface, and it helps in maintaining that low pressure center at the ground surface and intensifying the formation of tropical cyclones. Besides this, there should be no large change in the wind speed and direction with height. So if the region experiences low wind shear conditions, in that case also the cyclonic development is very extensive, because cyclones rely on the development of tall columns of convective clouds which extends from the ground surface to nearly 10 kilometers vertically in the atmosphere. So if you have a low wind shear, the formation of these tall columns of convective clouds becomes very, very extensive. If the wind is changing too much with the height, these columns of cloud cannot form and are not able to maintain that vertical height, and the tops continuously blows away with the wind, leading to ill-developed conditions for the formation of tropical cyclones. Besides this, a pre-existing disturbance in the atmosphere is also very important for the formation of tropical cyclones. So if any disturbance exists in the atmosphere prior to the formation of tropical cyclones, like the small disturbances which exist in the atmosphere, it creates a kind of seed for the tropical cyclones to develop. It can be an enhanced thunderstorm activity or low pressure trough also, which already exist in the region. So these type of conditions helps in the formation of tropical cyclones, and few very intensive tropical cyclones of the world originate from the small tropical disturbances which exist prior to the formation of these tropical cyclones. Now, once all the conducive conditions required for the formation of tropical cyclones exist in a place, the mechanism for the origin of tropical cyclones begins. The development of tropical cyclone is a very complex process, and it is still the matter of much research. However, it is evident that the tropical cyclones form over the large ocean bodies of relatively warm water which are located in the tropical latitudes of the world. And tropical cyclones are like giant heat engines which are energized by the latent heat of condensation, because they extract much of their energy from the upper layers of the ocean, and it converts the energy which is available from a warm ocean surface into strong vertical air currents, achieving horizontal wind speed via the evaporation of warm waters from the ocean surface and the subsequent condensation of this water vapor in deep columns of cloud around the center of the storm. So as you can see in this diagram, when the sea surface temperature reaches the optimum level for the formation of tropical cyclone, that is more than 26 degrees Celsius, the evaporation from the warm tropical oceans begins, and the pre-existing disturbance in that particular zone channelizes the energy, leading to the initiation for the beginning of tropical cyclones. And once this evaporation process starts, huge towering cumulonimbus cloud starts forming, leading to the condensation of this water vapor once it reaches the greater heights in that cumulonimbus column. So this deep cumulonimbus cloud often forms an almost circular ring around the eye wall, around the very center of the storm, which is itself free from cloud. And as the system starts to form, evaporation from the ocean surface acts as the source of heat and moisture for the formation of these deep clouds. And as long as the ocean surface is able to maintain temperature above than 20 degrees Celsius, this evaporation continues to exist, which feeds this developing tropical cyclone. As these storms continue to develop, the evaporation from the warm oceanic surfaces provides more and more heat and moisture to the clouds, feeding them, and they start developing into vertical towers. And it also helps the rising air current within them to get stronger and stronger, thus intensifying the surface winds even further. So as the warm ocean continue to produce the warm air, the water vapor continuously in this air funnel starts rising. And as the water vapor starts rising, there's the formation of cumulonimbus clouds within this region. So this continuous ascending of warm air leads to the formation of low pressure center near the ground surface above these warm oceanic water surfaces. And if at this point you have developed anticyclonic conditions in the upper atmosphere, it helps in intensifying the existing cyclone, because the existing high pressure in the upper atmosphere pull these ascending winds which diverge in the upper atmosphere because of the existence of high pressure in the above atmospheric regions. And this anticyclonic conditions in the upper atmosphere help in intensifying this low pressure center at the ground surface. So as the system develops, you have a very well defined central eye region of the cyclone, which does not have much of the wind circulation and which is free from clouds, and it is clear calm region of the cyclone. But along the outer margins of this eye, you have eye wall, which experience heavy formation of clouds, and the cloud band spirals in this particular eye wall region of this tropical cyclone. So as the system develops, the earth rotates and consequent Coriolis force act on the intrusion winds. So as the winds from the outer margins, from the high pressure regions of this tropical cyclones gushes towards the center of this tropical cyclones because of the existence of low pressure central core region near the surface, these winds start spiraling towards the center because of the existence of Coriolis force, and they kind of achieve rotatory motion around this low pressure region. Because of the existence of Coriolis force, you have counterclockwise rotation of winds in the northern hemisphere, and you have clockwise wind movement in the southern hemisphere. These tropical cyclonic systems, they develop into more severe weather systems with heaviest of rain and strongest wind movement, which are strongly focused in the central region of the cyclone near the eye wall region, which is the outer region of the lowest pressure region called as the eye of the cyclone. So the region surrounding the eye is called as the eye wall. So these winds are strongly focused in the center of the cyclone, and once they gushes towards the low pressure center, the formation of clouds takes place towards the outer margins, which is called as the eye wall. And once they develop, they tend to move westward under the influence of trade winds, causing massive destruction to life and property, especially when they hit the coastal regions of the continents. So as we have discussed in the earlier slide also, that since they are located within the trade wind belt zone, once they form, they tend to move westward. So they are primarily found in the western margins of the oceans or eastern margins of the continents. So as the tropical cyclone becomes extensive and begins to grow, the clouds intensify and strong rising air currents develop in the eye wall region of the tropical cyclone, which is around the storm center. So near the Earth's surface, the low pressure exists because of continuously rising warm air, which is coming from the warm oceanic surfaces. And as long as the temperature of the ocean is maintained above the 26 degrees Celsius, the ocean keeps on feeding this tropical cyclone and maintains the low pressure center. And as this warm air continue to rise up, it leads to the formation of vertical drafts of air which continuously ascends from the oceanic surfaces towards the upper atmosphere. And in the process, the low pressure central core region is formed, which is called as its eye. And as we have discussed, that eye is fairly a calm region which is free from clouds. But around this low pressure central region, you have eye wall. So these rising drafts of air, once rise up sufficiently in the upper atmosphere, they tend to condense around this eye wall So the eye wall is embedded by the formation of trail of clouds, which leads to heavy precipitation. So near the surface, the air is drawn into the center of the storm to replace the rising air. This inrushing air near the surface results in strong winds, which increases the evaporation from the ocean water. So now you can see that it has become into a cyclic system where the warm air from the ocean is rising and it is ascending upwards, and once it is ascending, it is leading to the formation of these huge globular cumulonimbus towering clouds, and within this cumulonimbus clouds you have the strong updraft of air around the eye wall region, and since the air is continuously ascending upwards, it is being replaced by the warmer air from below near the ground surface, which is again being attracted towards this low pressure center which exists near the ground surface. And this happens until the sea surface temperature of this oceanic water is more than 26 degrees Celsius. So the tropical oceans of the world act as the source of heat and moisture to feed this ever-growing cyclone and further deepens the formation of clouds in this region of the world. And once the cyclone develops, it becomes very, very extensive and it continues to move westward under the influence of trade wind until it either hits the land along the eastern continental margins or it is somehow dragged beyond the tropical regions of the world, which marks the beginning of its dissipation, because in those regions the ocean water is not warm enough to feed the tropical cyclone. So this tropical cyclone gradually die off, which marks the dissipation of the tropical cyclones. Now coming to the dissipation of tropical cyclones. When a tropical cyclone moves into a hostile environment, it will either decay or undergo extratropical transition. So what does this mean? As we have studied in case of temperate cyclones, that the formation of temperate cyclone is primarily dependent upon the formation of fronts and the collision of contrasting air masses along this front. And the temperate cyclone is aided by this continuous collision of contrasting air masses, which maintains the low pressure center. And as the warm air is completely occluded by the cold air which invades the warm air territory completely, it leads to the dissipation of temperate cyclone. But unlike temperate cyclones, in case of tropical cyclones, there are numerous factors and conditions which leads to the formation of tropical cyclones. So there is not one single factor because of which the dissipation of tropical cyclones takes place. There can be array of factors which may lead to the decay of tropical cyclones. So let's see what are those factors which may lead to the dissipation of tropical cyclones. So it can happen because of various factors, or it can happen because of prevalence of any of the one conditions which is given below. So first condition is strong vertical wind shear. So as we have studied in the conditions which are necessary for the formation of tropical cyclones, one of the important factor is the existence of weak wind shear, which ensures vertical development of cumulonimbus clouds, and these cumulonimbus clouds are continuously aided from the warm air which is ascending from the warm oceanic surfaces in the tropical regions of the world. So because of any conditions, if this weak wind shear cease to exist and strong vertical wind shears takes place, it leads to the hostile environment in which the tropical cyclone cannot grow, and therefore it gradually dies off. Second important condition is the cool ocean temperatures under the storm core, which is less than 26 degrees Celsius. So another important condition which we have studied earlier for the formation of tropical cyclone is the existence of higher sea surface temperature, which has to be more than 26 degrees Celsius. And in this high sea surface temperature conditions only, the warm air begins to rise up and it starts evaporating and leads to the formation of low pressure central core region above the oceanic surfaces near to Earth. So if due to certain conditions, if the sea surface temperature drops below 26 degrees Celsius, the supply of warm, moist air is cut off, which feeds and aids and helps in maintaining the low pressure central core region of this tropical cyclone, and gradually the tropical cyclone dies off. So it is another hostile environment in which the tropical cyclones cannot thrive. Another condition is the dry air intrusion or loss of moist air. We have studied again this particular condition when we were discussing the important conditions which are required for the formation of tropical cyclones is the existence of anticyclonic conditions in the upper atmosphere, which helps in maintaining the low pressure central core region near the Earth's surface above the warm tropical ocean systems. But because of certain conditions, if this anticyclonic condition cease to exist in the upper atmosphere, it does not aid the maintenance of low pressure centered at the ground surface. Under specific conditions, if suddenly the air from the aloft instead of ascending starts descending, it kills the low pressure central core region of the tropical cyclone and there is sudden descent of air from the upper atmosphere. Dry air intrusion is a coherent region of air descending from near tropopause level, that is in the upper atmosphere. So because of certain specific conditions in the atmosphere, if the dry air from the upper region starts descending towards the ground surface, it does not aid the low pressure core region near the ground surface and the cyclone gradually dies off. And fourth condition which leads to the hostile environment in which a tropical cyclone cannot survive is the landfall. So this condition also we have discussed while we were discussing the conditions required for the formation of tropical cyclones. And we have discussed that the tropical cyclones generally formed in the intertropical convergence zone region where the trade winds collide. So once the tropical cyclones are formed in the trade wind belt region, they are dragged towards the west under the influence of trade winds. And if they hit the coastal regions of the continent and start moving gradually towards the continental interiors, suddenly the supply of warm moist air which was being sourced from the tropical ocean waters is suddenly cut off. And in the process, the cyclone leads to heavy precipitation in the coastal areas which face massive destruction, which is called as the landfall of tropical cyclone. It starts unloading all the water vapor from it, leading to heavy precipitation in the coastal regions. And when it gradually starts entering the continental interiors because of the sudden cutoff of warm and moist air, it gradually dissipates and dies off. So these are the conditions in which the tropical cyclone dies off gradually. Besides these conditions which lead to the development of hostile environment in which the tropical cyclone finally decay and dissipate, there are certain extraordinary conditions in which the tropical cyclone may also undergo extratropical transition. Now, what does this mean? It means that sometimes the tropical cyclone is so extensive, it is so intense and strong that even if it crosses the tropical region and enters the higher latitude, it does not die off completely and it undergoes transition to develop as extratropical cyclones. So whatever is left in that tropical cyclone after it has crossed the tropical regions of the world and entered the higher latitude, so whatever is left in that tropical cyclone, it undergoes transition and aid the formation of extratropical cyclone, and in a way it undergoes extratropical transition and sustains itself and aid the development of extratropical cyclones in the temperate regions of the world. So the dissipation of tropical cyclone may either happen in form of its decay or it may undergo extratropical transition. Now coming to the global distribution and movement of tropical cyclones. So most of the tropical cyclones, as we've discussed, develop over the ocean surfaces between 6 degree to 30 degree latitudes in both the hemispheres. And in these tropical latitudes of the world, they greatly influence the weather conditions, especially along the eastern coastal regions of the continents, because they move westward under the influence of trade winds. So trade winds drag them along the western margins of the oceans or towards the eastern coastal continental margins, where they greatly impact the day-to-day weather conditions and overall climatic conditions of these areas. But within the tropical belt region also, worldwide, 6 major regions of tropical cyclonic activity have been identified. So as we know that broadly these cyclones develop between 30 degree north to 30 degrees south in both the hemispheres. But even within the tropical belt also there are certain specific regions where the frequency of the tropical cyclonic activity is very high. So they are called as the breeding grounds of these tropical cyclones. So let's just see what are those 6 regions. First region is the West Indies, Gulf of Mexico, Caribbean Sea region. In the central and northern Atlantic Ocean, the frequency of tropical cyclones along this region is very high. And it may be pointed out that the occurrence of tropical cyclones are rhythmic in nature because they are restricted to a certain season of a year, which varies from one region to another depending upon whether the summer season is existing in the northern hemisphere or in the southern hemisphere. So alone in this North Atlantic, Central Atlantic region, on an average, about 7 cyclones develop every year in this particular region. And once they form, they tend to move westward and hit the coastal cities of southern North American states along the western Atlantic Ocean. Sometimes the cyclones which develop in this region also enters the Gulf of Mexico and reaches the Central American Mexican region along with the Caribbean Sea region of Central America. And all these cyclonic development activity takes place primarily between the time period of August to October. And sometimes they attain gale force and they can be very destructive in nature. Besides this, along this area only, you have tropical cyclonic activity along the eastern Pacific coastal region also. So in this region, the cyclones after originating off the western coast of Mexico, sometimes they move westwards and northwestwards and affect the weather conditions of the California and southwest North American region. So during this time period, they can affect the southern North American region along the western coast, and they can also affect the Central American region also. Besides this, heavy tropical cyclonic activity is also witnessed over the western North Pacific Ocean along the China Sea and southern parts of Japan along with the coastal regions of Philippines also. So in these regions of the world, very intense cyclonic activity develops especially during the time period of June to December, and they have disastrous effect on the eastern coast of China and Indochina Peninsula also, and even the southern parts of Japan are also affected by the cyclonic activity which develop in these regions of the world. So you can see that cyclonic activity in these regions is so intense that sometimes the cyclones are also dragged to the upper latitudes also along this region. Besides this, you have intense cyclonic activity in the Indian Ocean, especially in the Arabian Sea region and in the Bay of Bengal region. After the cyclones originate either in Bay of Bengal or the Arabian Sea region, they greatly affect the coastal environment along the eastern coastal region of Indian Peninsula, and they also affect the weather conditions along the southern regions of Central Asia also. Besides this, another region is located in the South Indian Ocean region. So Indian Ocean is quite active in terms of cyclonic development and cyclonic activity, and between January to March, intense cyclonic activity and formation of tropical cyclones is witnessed along the eastern coast of Madagascar and eastern coast of southern Africa, also along with Mauritius and Reunion Islands, which are located in the South Indian Ocean region. And the final major tropical cyclonic activity region is located in the western South Pacific region, wherein the cyclones originate along the central Pacific region and then they tend to migrate westwards and hit the eastern Australian coast and various islands which are located in the southern Pacific Ocean, and they greatly influence the weather conditions of the northeastern coast of Australia. So these are the 6 major regions of tropical cyclonic activity. You can also see that the frequency of tropical storms and tropical cyclone in these regions is also very high. Alone in the western northern Pacific Ocean, in this particular area, the frequency of tropical storms and cyclones is very high. Nearly 20 to 25 cyclones on an average develop in a particular year time period, and few of them also attain gale force with damaging outcomes when they hit the coastal regions of the continents. So along with this, you can also see that the Australian and South Indian Ocean and Southwest Pacific region is quite active region in terms of tropical cyclonic activity, and nearly 15 to 20 cyclones in a year can develop in these regions of the world. So this is the global distribution and movement of tropical cyclones. Now, sometimes along with this global distribution and movement of tropical cyclones, there are certain regional and local conditions which also affect the distribution of tropical cyclone. For example, in the northern hemisphere, the tropical cyclones are tracked to higher latitudes primarily because of the presence of warm clockwise oceanic currents just like Kuroshio current and the Gulf Stream currents. As compared to southern hemisphere, the northern hemisphere experience more closed circulation of oceanic currents, just like the existence of Gulf Stream in the Atlantic Ocean and Kuroshio in the Pacific Ocean, because of which these ocean currents which come from the lower latitudes drag the tropical cyclones sometimes towards the higher latitudes also, and in the process they continuously feed them also because they are warm ocean currents. So as you can see, in the northern Atlantic region, the warm waters of the Gulf Stream supply energy to hurricanes as they move along the eastern coast of the United States, allowing them to survive for a very long time period, and in the process sometimes they are dragged to as much as 40° north latitude in these regions of the world. And opposite to this, the tropical cyclones are very rare in the South Atlantic Ocean, although there are occasional occurrences, primarily due to the consistently strong wind shear and weak intertropical convergence zone. So you can see there is a contrast in the same ocean only, that where in the northern regions of Atlantic Ocean you have very strong tropical cyclonic activity, whereas in the southern Atlantic Ocean region the tropical cyclonic activity is very less, prominently because of the strong wind shear and weak intertropical convergence zone. Also, conversely, beside ocean currents, the jet stream also tend to play role in the movement existent formation of tropical cyclones. So you can see that the African easterly jet stream and areas of atmospheric instability give rise to cyclones in the Atlantic Ocean and the Caribbean Sea region. So this African easterly jet stream greatly aid the formation of tropical cyclones in these regions of the world. Besides this, cyclones near Australia owe their genesis to the Asian monsoon, and the existence of Pacific warm pool. So you can see that there are various regional conditions also which helps in the formation of tropical cyclones, which may lead to condition where a tropical cyclone may attain a very extensive character, and it may develop into very severe disastrous natural hazard also in specific conditions. Now, sometimes the tropical cyclones become very extensive, and in the process, they attain gale force with tremendous wind speed, and they cause massive precipitation, causing widespread destruction. So, such type of tropical cyclones, which grow into severe natural hazards, are called by different names in different regions of the world, although they share the same characteristics and have the same properties. They are called by the name of hurricanes in the Atlantic North American region and in the West Pacific region of the world. Besides this, they are called by the name of cyclones in the northern and southern Indian Ocean, and they are also called by the name of typhoons in China and Western Pacific region, whereas in Japan they are called by the name of typhoon, and in Philippines they are called as Pegu. And finally in Australia, especially along the eastern coast, they are called by the name of Willy Willies. So you can see that although it is same type of cyclone, but different regions of the world use different names to describe the cyclones and cyclonic activity, primarily of same nature, characteristics, properties, and intensity. So, summarizing the video for part 1 of tropical cyclones now. A tropical cyclone is the generic term for non-frontal low pressure system which develop over the tropical warm waters around the world. The system generally have a well-defined center of low pressure which is surrounded by deep atmospheric convection and a closed wind circulation at the surface. They primarily develop over the warm tropical ocean waters during the late summer seasons and move westward in the trade wind belt within the intertropical convergence zone. And certain specific conditions are required for the development of tropical cyclones, like the supply of warm moist air, the sea surface temperature which has to be more than 26 degrees Celsius, and weak wind shear along with the developed upper anticyclonic conditions, and such type of conditions primarily exist in the tropical regions of the world. So leaving 5 degree north and 5 degrees south of equator, they mostly develop from 5 degree to 30 degree north and 5 degree to 30 degrees south in both the hemispheres. These tropical cyclones are heat engines which are energized by the latent heat of condensation, and they extract much of their energy from the upper layers of the ocean which are very warm, and they are the constant supplier of warm moist air to the tropical cyclone. So they primarily develop due to low pressure when the sea surface temperature over the tropical oceans cross 26 degrees Celsius, and they primarily derive their energy through the evaporation of water from the ocean surfaces, which ultimately condenses into clouds and rain when moist air rises and cools to saturate. And they dissipate due to numerous hostile conditions which are associated with either vertical wind shear or cooling down of sea surface temperature below 26 degrees Celsius, dry air, or landfall which cuts off their moisture supply, finally leading to their dissipation. And in the world, primarily they are found in the tropical belt which extends from 30 degree north to 30 degrees south in both the hemisphere. But within this belt also you have specific regions of the world which are 6 in number, which cover areas along the western and eastern Pacific region, central and Western Atlantic Ocean, and extensive cyclonic development is also witnessed along the northern and southern Indian Ocean also. So within the tropical zones, you have certain embedded regions which are considered to be the breeding grounds of tropical cyclones, and they experience very high frequency of tropical cyclonic activity throughout the year. So this was all about the part 1 of tropical cyclones. The rest of the topics will be covered in a sequence video, which is the part 2 of tropical cyclones. So I hope the video was informative. Thank you so much.